Microphone check 1, 2. Okay, let's do some Tiger Beetles. Let's do some Tiger Beetle. It's Tiger Beetle time. Tiger Beetle. Tiger Beetle. Hi, my name is Brian, and I'm here to hack on Tiger Beetle. This is a stream where I'm working on the Tiger Beetle Rust client. Tiger Beetle is, of course, a financial database written in Zig. It has clients for most languages, but not Rust. So on this stream, over many months now, I am developing the Rust client for Tiger Beetle. This client is a binding to a library called TB client. All Tiger Beetle clients are bindings to one library that has all the core logic. That library is written in Zig. And our Rust client is a very simple wrapper that is supposed to present some idiomatic async Rust. We're at the stage where, for quite a while now, we have had a PR in with the initial client development, and we've been doing rework based on the review for that PR. It's been slow going. It's been like 2 weeks since I've been here last. If you recall, last time I was telling you, I feel like I got a cold. I did have a cold, pretty bad cold, but I'm back now, back in the saddle. So this stream is going to be just kind of revisiting that PR, regrouping, figuring out where we are, what needs to be done, maybe getting a little bit of work done on making progress towards making that PR mergeable. Anything else we need to cover before we go get to the code? Yeah, let's go get the code. All right, so here is our code. And the first thing I'm going to do is we're not going to rebase because, as I mentioned last time, there have been some changes upstream that are going to break us. So we kind of can't rebase until we're committed to fixing those breakages. But what I do want to do is just go remember how to build all this stuff. So I'm going to go to the directory for the Rust client, which is in source clients Rust. I'm just going to say cargo clean and then cargo test. Now, as I recall, last time we had finished up, I think, replacing bindgen with a customs bindings generator. And on the PR, we've got like one major item that we have to tackle that's going to be pretty tough. And then I think just one little request that is going to be easy, or maybe we've already finished, so we'll have to go look. And then on our own, in our code, we have a little list of to-dos that we got to go either resolve or punt for the future. I think a lot of them are just going to end up punting because they're not like directly related to the Rust client. Like we've uncovered some little flaws in the Tiger Beetle clients generally, but we're probably just going to have to circle back to those at some point. All right, so, okay, we remember how to build. That all looks promising, more or less correct. Let's go again, review the pull request and see what the state of the pull request is. Okay, so I'm not going to go over most of this. I'm going to refresh it though. You see, I made this on January 27th. It is March 14th today. So almost 2 months. Not a super strong showing here for old Brian, but we'll get it done. We're going to get it done. Okay, I'm just going to go look at what all these comments are, what's left that I haven't resolved. This is the big one. This is our reviewer wants us to make all of the pub types literally the same types as the underlying Zig ABI, which, bleh. Don't know how I feel about that, but we're going to do it. This one I feel like we've done. So here, this is just a slightly different pattern for sending a signal through a Rust channel. I think we've done that. Let's go real quick and look at this one. I think this is done. So basically, here's a channel, and the only purpose of this channel is to just send a done signal, like with no payload, from one thread to another thread. And the way I'm doing this here in this diff is by just sending a nil value across the channel. Nil value has no size, but it does kind of imply sending an allocation. Not really. No, it doesn't even require a new extra allocation to send that message. This is a one-shot channel, so you're paying for that allocation to share the state between threads no matter what. But the reviewer asks us here to, instead of sending a nil value, just close the channel and have the receiver detect that the channel is closed. It's a potential pattern for sending a signal with no payload in Rust. Let's go look at the code. I think we've resolved that one. All right. What line was it on? Line 254 of lib.rs. All right. Tiger Beetle, source clients, Rust. You're going to have to forgive me if I have to get off camera and sneeze and blow my nose a few times during the stream. I'm not 100% yet. I'm 95%. Interesting. Interesting. Is this? I thought that I had a bunch of little to-dos written right here. Maybe they're in a different file. Must be in a different file. I think we said line 256. Yep, so I've already done that. You can see this is now a channel of infallible. All right, let's just go back over to our thing and our pull request and mark that as resolved. I'll write a little done message. This is done. All right. So it's only this big item here. And this is just another question asking me if I was going to do that big item. And I said, yeah, I'm going to do it. I'm going to do it. I'm going to do it. What is this one? So there's an issue here about how to define errors. Let's read this. So this one's tricky. Let's see if we can expand this in some way. I always kind of forget what things you click on GitHub pull request to show what. There's just so many clickables. Where is his comment? Now I don't have his comment. Comment, comment, comment. Oh. This is in lib.rs line 503. Oh, it's interesting. Okay, let's expand that. So somewhere down here, we should find his comment again. All right, so this is create transfer result. And this is actually an error type, I believe. You can see here it implements error. Create transfer result exists This one's tricky. Exists is not necessary an error. So you might send the same, what is this? Transfer, create a transfer. Transfer is just a transfer of value in the Zig in the Tiger Beetle financial database. So it might be that the transfer has already been done and you get an exists. Hmm. So, okay, he's saying this whole thing shouldn't even be an error. So I'm a little frustrated here, y'all, because honestly, the direction that we're taking this is that it's not going to be an idiomatic Rust API. It's just not. So this is not going to be an error. You're just going to get some enum with a whole bunch of statuses that you've got to handle. Most of them are errors. Some of them are not errors. It's a little frustrating. But don't implement error, but put it in a result. All right, so what he's saying here is that these are not necessarily errors. They're just kind of like the results. So we're not going to implement an error, but he is also saying do return a result of something, okay, or this. But if this doesn't implement an error, it doesn't make sense to use result because results are for errors. You almost never see a result that doesn't return an error. But he's also only saying it for create transfer result. But there's all kinds of other types of, well, there are several other types of results like create account result. And I would hate to do something different for create account result than create transfer result. So what I'm thinking here is to kind of go in the direction he wants us to go in, but not do exactly what he's telling us to do. Because I definitely disagree that we should not implement error but use a result. That does not make good sense to me. That's very unidiomatic. So what I'm thinking is to do what he's saying not to do here, is to use create transfer result, but just put an OK variant in create transfer result and not return a result at all. Just return this create transfer result. So you're not going to get any of the nice, question mark behavior in Rust. You're going to have to, manually handle, whatever these cases are. And you're going to have to know that, for example, this exists is probably okay, and you don't even need to think about it. Like if you see this exists, it's just like, fine. Really, my inclination is to just have this code check for exists and be like, yeah, don't worry about it. We're going to handle that case. Because there's almost nothing you can do in response to exists, right? It's just part of the normal operation. Sometimes that transfer already exists and you don't need to think about it. There's nothing that I can think of to do, but I'm not a domain expert here, so maybe there is some case where you could be like, yeah, I need to do something if the transfer already existed. I wonder if exists is another case in. Yeah, there's also an exists for this one. So he's talking specifically about create transfer result, but I think he's really talking generally about all these results. It's a little frustrating here. It's a lot of mismatches between Rust, what we should do in a Rust API, and what the Tiger Beetle API does. The Tiger Beetle API is not designed like a Rust API. So what I think we're going to do is we're going to just remove this result, add the OK variant here, and just let callers just deal with it. We're basically going to be passing the Tiger Beetle Tiger Beetle API as is all the way up to the Rust stack. It's just going to look like a Tiger Beetle, like the Tiger Beetle API, not like a Rust API. It's frustrating. It's frustrating. Anyway, let's get over it. Keep moving. But this thing is an error. Okay. Okay. What is this? All right, we've already looked at that. Okay, let's do one more thing we got to catch up on and just look at our own to-dos, our personal to-dos. I think they must be in main here. No, we don't even have a main function. Let's look at rg to-do. Ah, there it is. Rustbindings.zig is where we've kept our little list of to-dos. Where does that live? Here? There it is. So this is a file that is run. Oh, this is a Zig file. So it's a Zig source code that is run by the Tiger Beetle build system in order to generate Rust code. This generates this file right here. And I put some to-dos here. I just want to look at these and think, what here do we have to do and what can we just punt on? Don't double prefix. Okay, this is just naming stuff, internal naming stuff that probably doesn't matter too much. We can clean this up if we really want to in the future. It doesn't affect the public API. This is potential dead code in the C bindings generator. This build script rebuilding is also not critical. Users are not going to run into that. It's just people developing this particular Rust client. Hacked struct type defs are not. We fixed this last time. That is fixed. Use Zig names for structs. So I'm just going to put this here. And then I'm going to push this to another branch for my future reference. All of the stuff we're going to punt on this PR. None of this stuff matters to our reviewer, and it's all kind of internal stuff. So I'm just going to push this whole branch to Rust client to do. And then I'm going to remove all of that. And commit this as commit all amend. Oh, not no edit. We are editing. It's a message -m. Okay, what do we have here? Let's look at that diff real quick. Okay, that looks right. Okay. So we've just solved like 4 to-dos. That's nice. And now the only thing really is to tackle these comments that are problematic to me. Yeah. Okay, let's just do it. Let's just do it. All right, let's look at this code and see if we can figure out what a good starting point is here. All right, so here's our API. And so what he is asking for is for this to be ABI compatible with the Zig definition. Let's go open those Zig definitions. This is going to be in Tiger Beetle .zig, I think, and it's called, there it is right there. This account flags. Hopefully this bit flags macro that we're using here will be, I mean, it's just going to be a U16. I think this will work. And so to start with, I'm just going to literally make this ABI compatible with this. And we can open tbclient.rs as well. So here's the Rust version that is defined by our bindings generator. And these should be the exact same size and have the same fields. But in the Rust world, I have not declared this repc. And my rationale there was like, this is a Rust API. Who cares about the C representation? But what we can do, and so we have a conversion step where we convert internally from the underlying over-the-wire representation to the Rust representation. And if we want this, okay, here's another special type here. So this account flags is a special type. This has to have a defined binary representation for this to work. This is also, this reserved here is a type we've defined in order to represent reserved bytes. We have to have a defined representation for this to work as well. Otherwise, we're going to have to find some other solution. Like probably right now, if we put repc on this account, it's likely not going to work because we don't have repc on reserved. We can go test that. But if we make this repc, and then we can just basically do a bit cast, a bitwise cast from the over-the-wire type to the Rust type, and it will just work. It'll be an unsafe cast, but it'll work. And if we didn't want it to be unsafe, we could pull in like, there's a crate called Zero Copy. I think it's called Zero Copy that handles a bunch of common unsafe conversions in a safe way that we might be able to use. But likely what we'll do here is we'll, make this repc, and then at some point we could probably just have the bindings generator generate this type with the actual representation we want, but maybe not, because it's not going to make a lot of sense to have the bindings generator generate bit flags macros. Probably not. And anyway, I don't really want to, again, I like a clean separation between bindings code and library code. Like if we start intermixing all this bindings goop over here with our pristine Rust API, it's just going to be hard to read and hard to maintain. IMO. Anyway, let's take this. I'm feeling very conflicted about this. I'm not liking this at all. All right, let's take this repc and just put it there. And I think this will not compile. Let me see, do I actually... Okay, cargo check. Oh, I don't have my workspace primed. We're running the build script right now, and part of that is building those bindings by running the Tiger Beetle build. Okay, so this did build. That's a little surprising. Let's go look at this definition of reserved. Where is reserved? Struct reserved. Huh. Why is that allowed to be repc? I don't believe you. I thought the compiler would figure out that this is not repc, or this is not repc, so this shouldn't be allowed to be repc. Not feeling super good about this. Like this should probably be repr transparent. This is a one field struct. It just contains a bunch of bytes. If this is repr transparent, that is saying that this thing is emitted in machine code just like whatever is inside of it. Very confused about why this is just allowed to have a C ABI without a declaration on it. Let's see if this builds. This should build. That builds. Okay. Now this account is repr C, and again, this should have the exact same size and alignment as TB account. And we could assert this statically, but we have to pull in another dependency. To do it in a clean way, we have to pull in another dependency. There's a crate called static assertions that has a bunch of really convenient little macros where you can say, assert this thing that is known at compile time, which is kind of hard to do in vanilla Rust in a way that is pretty. But we can just make runtime assertions right at the point we do the conversion. So now what I want to do is go find the place where we're building this account and just do a unsafe transmute from one to the other. Let's go look for TB account T. Create accounts is dealing with account. I think that's probably the only one. Oh, here's another one here that deals with accounts. Lookup accounts. Here's another one, query account. So we have probably 3 methods here that deal with accounts. Let's just do one at a time. And again, we have like one smoke test here that tests all these things in the most basic way possible. So hopefully that'll keep working. Hopefully that's enough to make this change without breaking anything. And how does this work? What we're going to do is we're going to pass in an account here. The user passes in a Rust account, and we have to convert it to a, instead of a slice of a Rust account, we need to convert it to a slice of the Tiger Beetle TB account. And all of that happens here in this create packet method. Let's go look at that create packet method. And this is the thing that the reviewer was not liking. This method is a very ugly, highly generic method. And I'm just wondering right now whether we should maintain this method or not. Probably the thing to do is copy this whole, because it's used in probably every request we have right now. So probably the thing we have to do here is just make a copy of this and then strip out the parts that do the Rust conversion and just make it an unsafe bitwise conversion. And see, this takes a Rust event right here. These are our events. This is our input, an array of Rust types. And then what does it do? What does this thing do? This is a callback, so this happens later. All this code is written backwards. This callback is handling the result of our request. So down here is where we're doing this conversion right here. So we're iterating over the input and then converting it with this from method from the Rust type to the C type. So this is the thing we want to get rid of. We still can't avoid allocating this vector though. We're still going to create a whole vector to do this because we don't want to hold on to a reference to this array. We want to let that, look, this is an async function and we don't want to hold this reference across the entire request so that the caller can go recycle that allocation. So really, only thing we're going to do is just make this slightly different. We're really just going to, just slightly different. Okay, let's create another create packet method. Just copy this whole thing. And this is going to be, I don't even think we need to do that because really what we can do we already have, we still have two types involved here. Let's go to this. So we still have two types involved here, this type and the Rust type. It's just that now they have the exact same representation. So we can really just change that from implementation to be a bitwise copy. And honestly, we don't even have to change anything here. This should still keep working. We've just tagged ref_c, and we can make some assertions that, yeah, actually these two are the exact same thing. But if we go look at our conversions, it's probably from, no, the opposite of this one, from, oh, this is it. This is, no, this one. We're converting from a Rust account to a Tiger Beetle account. And you can see right now it does, you know, the kind of naive, safe thing, just copies fields. But what we can do now is we can get rid of this and do a bitwise copy, if I can remember how to do that. But this, honestly, this should still, the test should still work just like this, using the fieldwise copy. So we can make this change kind of in increments. We can go over here and maybe put in some asserts. Put that assert right here, probably. We can say assert. We can just make assertions about the size and alignment of these two types. How do I do that? Stood mem size of, I'm not sure if it's size of or not. Let's go look at the Rust docs real quick. That's not the Rust docs, that's me. So pretty. Rust docs. Docs.rs. Not docs.rs. Stood.rs. And mem module. Collapse all that. A line of val. And then a size of val. Okay. No, we're gonna have to use a line of type, not a line of val. Yeah, a line of type. We only have one of the values here, not both of them. So we're going to say size of account is going to be assert eq stood mem size of tbc tb account t. And then the same thing with, let's see, do we have mem imported yet? Nope. I don't think I'm going to bother to import it. Just make it fully qualified. And a line of. So for now, we can just do this. And in the future, we can go, you know, do an unsafe conversion between the two, and even just remove one of these types entirely. A line of, oh, these are type arguments, not value arguments. Yep, you're right, Danik Vitek. Needed some turbo fishes here. Vroom, vroom. I'm glad somebody's paying attention. Doesn't implement debug. Something doesn't implement debug. What is this saying? Binary operation cannot be applied. Oh, I still need to call the function. I was trying to compare the functions, not the result of the functions. Okay, and this should still just trivially continue to work. And that gives us some assurance that we have defined these two types exactly the same. And I'm going to commit a little checkpoint there. and do the same for all the other types that demand this treatment. So we've done account, and then transfer, we're going to do the same thing. Repr C, let's give it a look real quick and make sure we believe that they have the same representation. So here's the Tiger Beetle / Zig transfer on the right. Here's ours on the left. They visually appear to be the same thing. There's another one of these bit flags inside the Rust version, which is just going to be a U16. Though we might want to go look at the implementation of bit flags and see what exactly this spits out. This might end up being like a new typed U16. Maybe a const block is possible to use for the assertions. Maybe. I honestly do not really, haven't kept up with the state of const evaluation in Rust. I don't even think I've ever written a const block, but we can go. So Danik, you were saying it is possible to write this and evaluate that one block as a constant at compile time? Is that true? Const blocks, huh? Yeah, I was talking before about the static assertions crate, and maybe that is assert failed. Okay, so there's something about the implementation of this assert EQ that it doesn't seem to be compatible with const blocks. Okay. I'm gonna go to the web and really look up real quick what's the deal with that const block, because I don't think I've ever written a const block. Rust const blocks. Let's see if that comes up with any docs. It comes up with an RFC book, inline const. Is this a stable thing? Rust issue. Open still, maybe not stabilized, or maybe partially stabilized. Inline const. Ooh, that's neat. That's inching closer to what Zig can do. Const block in a match. Oh, that's Rust syntax is Rust syntax is like a hydra. It's just gigantic these days. Here, this is a const block. Another const block. These are all expressions. I don't see any const blocks that are statements, but presumably statements also work. Anyway, it doesn't seem to be compatible with the thing that we are trying to write at this very moment. So I'm gonna move on. Thanks for the hint, though. I wonder if those const blocks are stabilized at all in any capacity. Okay, so this bit flags. I'm just gonna assume that whatever they're doing here is C compatible. All right, this transfer, TB client, transfer, these look the same. So again, this should just continue to work. And if we go over to our conversions, you might as well, you see we have bidirectional conversions from the Zig type to the Rust type and the Rust type to the Zig type. I'm gonna take these asserts and just put them in both places. I think the performance impact of doing that at runtime is pretty negligible, but would be more desirable to do it at build time. All right, here's the one for transfer. So we're just gonna do the same thing. And again, this whole conversion might end up just disappearing completely as we go along. And there's another one for transfer in the other direction right there. And you can see there's some more types down here, but let's do one at a time. Okay, pretty trivial changes. Just checkpointing that work and moving on to the next one. All right, there's another one of those structs that we probably want to preserve the original Zig ABI on. Let's go again, just to visually convince ourselves that we can do that here. And here we have one of these big reserve types. And this is the reason we had to define a custom reserve type, or we decided to, because making a 58 element byte array here was going to be very unwieldy for the API, because a bunch of common Rust traits are not defined for 58 element arrays. So we made this reserve type to just do the things we need to do with that. Again, this is just another bit flag. All right, I believe these are the same type. And then we can go over again to our conversions and just keep following the pattern. Follow the recipe. Count filter, 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 filter. And it looks like we only have that conversion in one direction. And let's go, not get greedy, just do one at a time. Seems to work. Checkpoint that. And the next one is going to be query. Oh, there's account balance. Probably do account balance as well. TB client RS account balance. Do these look like the same type? They look like the same type. Let's go to our conversions. Account balance. Account balance. It's easy to accidentally type the wrong type here in the wrong place because there's no like actual relationship between these assertions and the types in the impl. I'm just double checking that this is an account balance and I'm writing account balance. Okay, that's repc. Let's just do one at a time. Don't get greedy. One at a time and don't get greedy. I'm gonna mess with my music though while we are doing all these compilations. Yep, we're done. Okay. Don't get greedy. Commit that. Query filter looks like it's next. There it is right there. Query filter, query filter. And again, we have a single smoke test that does test every one of these things. So hopefully we're not making any bugs right now, but it is just one smoke test. Test, don't get greedy. Play some music. is in. I think it's an A minor. No more music. Done. Checkpoint that. What else do we got here? Okay, then here we get into the error types. These are kind of a separate thing. And we probably don't want to attempt to make these ABI compatible. And we haven't been asked to make these ABI compatible. Let's see, is there any other conversions here? Create account. Okay, these are error types. Error types, packet status. Yeah, okay. Okay, I'm going to go collapse all these little commits. Get rebase. Actually, I'm going to just say get reset onto this thing. How do I do that? Get reset. Get diff. What up, Code of Misanthrope? Good to see you again. I know it's been a very long time. I was sick, but I also feel bad about it. All right, so what we've done here is, so today, Code of Misanthrope, I'm kind of tackling the last big request Alex made for me on this PR, and I'm really hemming and hawing about it because I don't love it much, but I'm doing it. Rework. Convert Rust types to C types. So we've taken all these things that we had here, and we had already defined them exactly the same way as the Zig types, but we had not actually explicitly said that they're C types. But now all we've had to do so far is just explicitly say, yeah, these have a defined binary representation. And now this query filter is exactly the same, or I believe it is exactly the same as the Zig type. I don't really have a guarantee that it's exactly the same, but I'm pretty confident. And now we have the option of kind of going back and making count. What is it? Struct account. So we still have these like this duality between the handwritten type and the code gen type, but at the binary level, they are exactly the same type. And we have the option of either, well, we can't remove the code gen. We got to leave the code gen. Do we? Yeah, got to leave the code gen probably. But we could unify these in some way. We could have like the code gen more sophisticated. For example, the code gen it would be trivial to emit the correct name here. But we also have to, in this case, like we have a special type here for reserved fields for technical reasons. And we're using the slightly nicer bit flag syntax for Rust instead of just making it a U16 and telling the user to just figure it out. And we could conceivably, have the code gen emit bit flags macros. That's doable. I don't know if I want to do it. And again, as I mentioned many times, I really like there to be a solid division between handwritten code and generated code. So I am fine just casting between these two types and having this type be maintained by hand with a few assertions that, we've done that correctly. So I might leave it like that, basically, and just see what the reviewer says. Let's see. Danique, I see your link. Something about const blocks, probably. That's what I'm betting. It's something about const blocks. I'll open it up and go check it out. How do I copy that? I'll switch over here and go browse some web. What is that? That's not the link. How do I copy your link? Code of Misanthrope, off topic. Oh, yeah, about the rewriting the TypeScript compiler into Go. I mean, I understand their rationale, their basic rationale. So the TypeScript compiler is being rewritten from TypeScript, I assume, into Go for performance reasons. presumably if they did it in Rust, they could make it even faster. But, they're doing it from one garbage collected language into another garbage collected language. And I think that alone is a pretty darn good rationale. Having to actually think about all those allocations and how to change each single one of those allocations to make them work in Rust seems like just a huge pain in the butt. So it makes sense to me that they're going to use a garbage collected language for their new compiler. And I'm not really sad about it. Like, there was a time when every single Rust win was a real big deal, right? But Rust has a pretty darn good stronghold at this point. Like, there's a lot of projects betting on Rust. So, but this one high profile project bet on Go instead of Rust. It's not an end of the world for us Rust zealots. Not that I'm a Rust zealot. I love languages generally. All right, let's look at this 1.79. This is where they announced const blocks, apparently. Thank you, Danik. Now stable in expression position. Okay. So at least some parts of const blocks are stable. The one I wrote was not in expression position. It was in statement position. But, sometimes statement position and expression position are kind of similar. They may not make that distinction. But we did get a compiler error when we tried to put that assert EQ, because assert EQ probably calls a bunch of little helper functions, and one of those helper functions seemingly was not const compatible. Let's look at this again. This can now be written like this. Okay. I guess that's interesting. This is useful information to know. I've definitely never written a const block this way. Const in, const in. Oh, and there is reference docs. We only found the RFC when we Googled for it. Thank you for the. That's right, Danik. Statements are basically degenerate kind of expression. Yeah, I'm not going to dig too deep into this right now, but good to keep in mind that there is such a thing as const blocks, and that might be useful sometimes. All right, what do I need to do next here? So far we actually haven't. I'm going to go look at his comment again, because I feel like we haven't actually accomplished anything interesting or useful here just by putting repc on these. Try to understand a little bit more about kind of what he actually wants to get out of this. Because I feel like that big conversion function is the real problem here. That giant, ugly, generic conversion function that has a bunch of allocations in it. And we have not actually tackled that at all. We should avoid any conversions here. Avoid any conversions here. Make sure the pub types are API compatible. So we've made sure the pub types are API compatible. We're still doing a conversion. Okay, we can go back and make these conversions, at least, do the bitcast. I suspect in practice, it's not actually going to matter because of optimization. Optimizer can see through this pretty easily. But if we look at our conversions here that we've left behind, we're still doing like a field-wise conversion here. Oh, and this right here, this is probably not transparent to the compiler. There's probably some stuff going on here that is going to prevent all this from just ending up being a big old mem copy. Okay, here's another potential problem here. Is it okay? So with our bitflags macro, it is a U16, but is it undefined behavior if we accidentally see a flag that we don't know about? Like what happens? We've seen this kind of issue before where like the CABI is just not type safe enough for us to like define it in ways that we would like, because like what if the wire sends us an enum that we haven't defined, and then we cast that into our Rust enum and then it's instant UB. So what happens if the server sends us an account flag that we don't know about? Like here, we're going to get an error. Here, like if we just do the mem copy for this whole struct, and this account flags field ends up with a value here that we've never seen before and we haven't defined here. What does that mean? If we want to make these have the same C representation, do we have to abandon using the bitflags macro? Kind of want to go look at the bitflags docs and see how this actually, what code this actually spits out. Like maybe it's okay if this is truly just a U16, not a new type U16, it's definitely not an enum. Like this could end up being something that we haven't defined, not UB, but also kind of like impossible to work with. Thanks, no sign. Hey, thanks, no sign. You're so helpful. You're always helping me. I appreciate it. So this account flags here. This account flags. I think I fixed it. Yeah, this account flags here. You know, it's a special Rust macro bit flags, and our goal here is to make this account the exact same thing as the C type and not do this conversion. Basically, do this conversion as a big old mem copy, a big unsafe mem copy, or not do the conversion at all. But probably the first step is just do a mem copy right here in this from implementation. But that has implications for this bit flags, which is frustrating. Let's go look at what the bit flags crate. I think the bit flags crate like has some examples of like what it actually emits. All right, I'm going back over to the web, and I will remember when we go back that I need to switch back the scene again. Macro example generated. Okay. Show me the source here. This doesn't really look. This is the code generated by the macro, but this is just more macros. I feel like maybe this is bit rotted. This example does not actually show me what the underlying code looks like. But if we go find this implementation of bitflag consts, internal bitflags, this is probably the one that actually emits the, or maybe this one? Well, this is frustrating. Public bitflags, internal bitflags. Yield 0, flags. So it is a wrapper struct. Not clear whether it's repr C or not. Yeah, I'm not getting warm fuzzies for what I'm seeing here. Like if this is not repr C, then we can't just assume that it is actually has the same representation. I wonder if we can just tag bit flags with repr C. Repr. Okay. We can just put repr on it, and it will probably just pass that through. Okay, that should help. Repr transparent. It's probably the thing to do. So the bit flags will let us pass through this attribute. And again, I'm going to go back to the code. Again, I'm kind of very surprised that the compiler did not look like threw this repc struct into the fields and see that this wasn't repc and just tell us we're not allowed to do that. Maybe there's a lint for it or something. Maybe there's a clippy thing that'll do that. In fact, I kind of want to go check right now. Let's see what the state of clippy is on this project. I'm just shocked. That's such a trivial thing to do. Clippy must do it. Like if the struct is going to be repc, then all the fields have to be repc. But in order to trigger that lint, let's go take that reserved struct and make it not repr transparent again. Casting to the same type is unnecessary. Oh, that could be useful. That's stuff we can go fix. That's from a fix we made last time. We changed some of the types involved here. I'm not seeing any repr. Not seeing any reppers. That is concerning. Well, let's do the thing that we know that is correct and find those bit flags and put repc on the bit flags, or repr transparent. Again, repr transparent just says for single field structs, have the same representation as the internal field, which in this case is a U16. Okay, that looks like all of them. We can cargo test that too. I'm really confused at why we got no complaints. Let's go fix this clippy thing. These are, again, I think in our conversions module. Let's have 5 seconds of music. Oh, 2 seconds of music. Lib, okay, not in the conversions module. 307. Okay, these no longer need to be. Yeah. So when we rewrote the bindings generator, we found kind of a bug in the C bindings generator we were cribbing off of and that the bindgen was also using. Previously, these were defined as U32s, all these C enum values, but now they're defined correctly. So we no longer need this cast. And it's probably the same for all these bit flags. These bit flags, oh, this one's already a U32. So just those bit flags. All right, let's see if Clippy's happy with that. Not quite, 803. Okay, here's another one, similar deal. All the enum variants are correct now. Okay, and we'll commit that as remove unneeded casts. And let's test the hypothesis real quick. If you recall from previous streams, sometimes our build script reruns when we don't think it should. And our hypothesis is that it has to do with the Git directory. So when you create a cargo build script, you emit some directives that say, if cargo sees these files have changed, we need to do a rebuild. And our hypothesis is that somehow we've accidentally said if the Git directory changes, if something in the Git directory changes, do a rebuild. So I've just committed. That'll change the Git directory. And now let's test again. Yeah, you can see right there. It's rebuilding the build script. So probably our build script is slightly wrong. And it's just saying, it's iterating over the entire .git directory and telling cargo that all of that matters to us, and it just doesn't. But again, it's not that big of a bug. You can kind of leave it forever and no one will even notice probably. You may circle back to it in the future. Okay, let's see, where are we in our commits? Converted Rust types to C types, and we fix those casts. And again, the thing we have to do here, so now let's just look at these bit flags again. I'm guessing it is probably, it's not undefined behavior if this transfer flags has a value that is not explicitly defined here. It's just going to be very confusing. So we can probably just go ahead and do the mem copy here, or the equivalent unsafe thing. Let's think about how to do it. I haven't actually done this kind of unsafe cast in a long time. So what we want to do for all these conversions, instead of copying the fields, although this is really nice to have, this little thing here, like we're gonna lose that check. I don't know, we can mention it in the PR. We can just, let's make the change and say like, here's the thing you asked for. What do you think about it? Here are some caveats about the thing you asked for. So instead of doing all this, we're just gonna do a cast, just a value cast. Let's see if there's anything better than a transmute. A transmute will do it. So we could say just stood mem transmute other, and that'll do it. That'll say, take their input and just treat it like the output. Let's test that and make sure I'm right about that. Of course, it's unsafe. Not unasf, unsafe. Yeah, definitely works. But let's go look at the standard library and see if there's any narrower function that does something similar. Not that. I think I don't necessarily need, I'll leave those. I might read them later. Stood.rs. And let's go look at the mem crate or mem module again. Okay, transmute, that's our big boy. Swap, replace, forget, drop, a line of, zeroed, forget, copy, copy. These are all experimental. I don't see anything here that is particularly better. All right, let's use transmute. And if there's something better, Matt Clad will know and he'll tell me in the review. Switch scenes. And we just do this unsafe for, copy this exact line for all of these. One thing we could do if we wanted to keep, let's go back real quick. We could just keep this like as an assertion. Count flags from bits, other flags. We could just keep that in there just like that as an assertion, which I kind of like. And then this. We'll see what our reviewer thinks of all this. But now we can kind of do, this all looks the same. This, just do the same thing right there. Let's see, how do I put this in a register? Copy to register. Let's use Emacs to copy that little snip. Register, insert, yes. Register, insert. Huh. Give me a second while I figure out Emacs again. There we go. All right, I think this one has a flags. So we'll do the same thing, just move that flags out there and use it as an assertion. And here. And down here, no flags on this one. Down here, no flags on this one. That is a good point, Anik. Transmute does have an assertion about the alignment for sure, probably also the size. So we don't actually need to assert that ourselves, and it's a compile time assertion. And it's actually very weird because it's like an assertion that happens at that code gen time, I believe, or at least it used to. So when you call transmute, transmute is very magical. Like it can't even be like its behavior can't even be represented as a Rust function, because it like has this assertion that the things you're passing to it have the same alignment and probably size, and that can't even be known. At least a long time ago, it couldn't be known. Maybe it can today until it hits code gen. So it won't even like trigger under cargo check. But when it gets to code gen, if it says these two things you're transmuting are not the same size and alignment, then code gen will error from that intrinsic, which is a very strange semantics. So probably don't even need this. You're right. That's only true if we use transmute. There's other ways to do this that don't necessarily end up in transmute. Maybe every possible way to do this ends up as bottoms out in the transmute intrinsic. Still, the documentation is pretty nice. I don't know if I want to remove it. We can see if it goes how it goes through code review. Okay, again, this is just another transmute. And I think I'd done all those. Test. And I still feel like we haven't really achieved the spirit of what MatCloud wants from us, because we're still doing a conversion. We're calling a from implementation. And like, we have ensured that the Rust types have the same exact layout as the C types. But there's no point, really, in the Rust API of having this have the same layout as the C types. And this is almost certainly not really a performance win. I just feel like we haven't really accomplished anything by doing this. We'll see. We'll see how it goes. Okay, I'm going to go look again here at this big old generic conversion function where those conversions are happening. Collect results. This probably has one of them. So the C event, again, every time I read this, I have to, let's not look at that one yet. Let's look at the easier one first. This create packet is converting a Rust event to a C event. And again, we haven't changed this at all, but it happens right here. And now this from implementation is different. And you would kind of like to get rid of this vector allocation, but I don't think we can get rid of this vector allocation just by having the types have the same layout. The only way we could get rid of this vector is by holding on to this reference, and I don't want to hold on to that reference. Yeah, there's kind of nothing to get rid of here. This all has to happen. So down here, handle message, see event, see result. Don't think there's a conversion there. This big gnarly function does have a conversion somewhere. Probably the C result is converted to the Rust result, but that is the error type. C event, Rust event is returning a Rust result wrapper. Vector of Rust result wrapper. Let's go look at how collect result is being called and just try to remember what this does. This method is so complicated. So this wants to return, again, this is either returning a vector of nothing or of an error, basically. This one, lookup accounts, is different. This is returning a result of either an account, which is one of our big types, or a not found. Collect results. So here it's calling collect results with TB account. Yeah, probably what's happening here is we're converting from C result to Rust result. I bet there's a from here that converts from the C result to the Rust result. This one right here. This into is doing that conversion. But again, there's not really any allocations we can save here. I feel like this is kind of as good as we can do without more feedback from our reviewer. So we'll kind of just give him this and be like, we made progress in the direction we think he's looking for, and he can tell us if he wants more. Rework. Use bitcasts for conversions. I should use the Rust terminology. Rework. Use transmute. All right, so the other thing that our reviewer asked us to do is to look at these error types. And let's open the same file in both places. So all of our requests right now return a vector of a result. So here, basically, we don't want these result types to be error types anymore in Rust. We just want it to be exactly the same as the underlying Zig enum. So this particular request, I think you probably can't see that on your screen. Let's put it over here somewhere. So this particular result here, we want this to look more like, instead of a Rust result of a nil OK or an error, the underlying API just says, this is a vector of a result, and this could be OK. And we wanted this to look more like this. So you're not going to be able to interpret the individual results as Rust error types. You're not going to be able to use question marks or anything like that. You basically have to put a match statement on them and do your own application-specific interpretation of whatever this means. This case is easy, though, because there's no payload here for the OK case. This case here, similar. This case is different, though. Aha. But this one doesn't actually return a result, like a status code. This is just something we've defined to say, like, we didn't find an account for this request. So this probably doesn't need to change at all. Let's see what other cases we have. Similar. It's either going to be a value or not found. This one is, again, a different case. Wait a minute. Packet status. Okay, they all potentially return a packet status because there's two levels of errors here. Like the request as a whole could fail with packet status, or any individual event of the single request could fail with a not found or with a create transfer result. There's basically get account balances, vector of account balance, vector of transfer. So there's only two methods here where this really applies. Create accounts and create transfers. So we're going to just want to change this to be a vector of create account result. I wonder if I want to do this tonight or not. It's already been an hour and a half, and we've kind of succeeded at my original goal of just getting back into this project and figuring out where we are and making some progress. So I think I'm going to wrap this up. Let me just make sure our commits are in a good place. Okay, and see if cargo format is happy. Cargo format is not happy. Ugh. Okay, commit that and go make sure it's attached to the right. I think that belongs on this commit right here. Let's say get rebase. Interactive. And go put those formatting fixes here. Oh. Ugly, ugly, ugly. Let's do this a different way. Let's do an interactive rebase. And reword this one. No, reword wasn't the right thing. Edit. Just stop right here and say cargo format. Amend this. Get rebase continue. And then just go fix these. Uh-oh. My Emacs fingers forgot a thing again. There we go. Oh, this is so ugly. I think I just want to keep that and get rid of that. Keep that. 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 Get rid of that. Let's see if that still works. commit, and run format one more time. Git rebase, continue, run format one more time, and cargo clippy one more time. And we committed, so we triggered our build script rebuild, our buggy build script. All right, here's our commit history. This looks fine. Git push. And we can go tell our reviewer that we made some progress. Again, if you're just joining us, we're actually about to wrap up. We're working on this rework for the Tiger Beetle Rust client. And we made some progress today. Maybe one more session and we'll be able to get this merged pending, well, I think a lot of these checks don't pass for some reason. You haven't even looked at those checks on the CI. But we've been addressing this comment right here. And kind of unsatisfactorily, I think we've done the thing that he's asking for, but I don't feel like it's really accomplished what he's hoping for. So I'm going to tell him, like, I've made some progress on this. Push to commit that changes the ABI. Push to commit that makes these types wrapper C with the same representation as the Zig types. As of now, they are still two types, two distinct types. One emitted by the code generator and one written by hand. The handwritten one is distinguished. The handwritten ones the ones written by hand have some stuff that is not in the code gen. They have the same representation, but in the Rust type system, they look different. Some niceties. So the conversions are still there, but they're transmutes now. This doesn't really seem it's not satisfying. It doesn't seem like it's fully what he's hoping for. And I'm going to say I'm still working on the error types. It's kind of unfortunate that I'm asking him to come take another look at it right now when I haven't fully finished doing the rework. But I do kind of feel like we need to say something about what we've pushed. All right, let's reread this and make sure I haven't said anything too fiery. This all seems pretty straightforward, though. Zig types, and there's still two distinct types. Under in my hand, still there, but they're transmutes now. Let's say in particular, those choose generic functions haven't budged at all. All right. Okay, again, I think we're wrapping up here. That's about it, y'all. So again, my name is Brian. Burson on GitHub, BRSON. My socials are there somewhere on my GitHub page. We're working on the Rust client. I know it's been a while and I haven't been consistent on this, but I'm feeling good now. Hopefully we're going to be making more progress more rapidly. I want to get this PR done. It's been 2 months and I'm kind of sick of it. Thanks for joining me, and I really appreciate everybody who helped me in chat. That is honestly very useful, and I appreciate you greatly. I'll see y'all next time.